Okay, in this lesson, in this segment, we're going to identify the inverse of a rational function. This takes a little bit more work than the other functions that we had transformed into their inverses, and so I'll just pay really close attention to a couple of the important steps. So we have our function here. This is a rational function. We have an x in the denominator here, and so we have a domain limitation. That domain limitation is not really going to be a problem in making the conversion, so don't worry about that. So we're going to take our function and we're going to turn it into y equals 13x minus 17 over 4x plus 9. Then we're going to turn the y into an x, and we're going to turn both of the x's into y's. So we now have 13y minus 17 over 4y plus 9. Okay, and so now what we're going to do is we're going to do what we normally do when we're dealing with rational functions. If we're trying to solve them, we want to cancel this denominator, and so in order to cancel the denominator, we're going to multiply by the denominator. So we're going to multiply by 4y plus 9, and of course we have to do that on both sides. So we'll multiply over here by 4y plus 9. Okay. Now over on the left side, all it's going to do is cancel the denominator. That's it. It's not doing anything else. It's just canceling the denominator. So all we have left on the right side is 13y minus 17. Over on the left side, we're going to have to distribute the x. So we have to do x times 4y, which is going to be 4xy. And then we have to do x times 9. So that's going to be plus 9x. And then on this side, we only have 13y minus 17. Okay? Now the next step is very important. Okay? Very, very important. We have to move every term. Having a y in it to the left side. Okay? We're going to move everything that has a y in it to the left side, and then everything else that doesn't have a y in it to the right side. Okay? All right, so let's just so we're clear. This term has a y in it. This term does not have a y in it. This term does have a y in it. This term does not have a y in it. This term is already on the right side. This term with a y is already on the left side. So we have to move this term over to the right side, and we have to move this term over to the left side. Okay? And so what we're going to do is we're going to subtract 13y. Subtract 13y. Okay, over here this is going to cancel. We're going to have 4xy minus 13y plus 9x equals negative 17. Now we're going to subtract 9x and subtract 9x. Here this is going to cancel. And moving up over here, we're now going to have 4xy minus 13y equals negative 9x minus 17. Okay. And so now the next step is a pretty fancy step also. So after we do that fancy step of moving everything with a y to the left and everything without a y over to the right, now what we're going to do is we're going to factor out the y. Okay, we're going to undistribute. I know that's not a real word, but that's one way of understanding it. So we're gonna take this y and we're going to move it to be by itself, and then we're going to open a parenthesis, and then we're going to rewrite everything without the y. So 4x minus 13. Okay? And then equals, this is going to stay the same, minus 9x minus 17. Okay. Now you can see that this works because if we were to multiply, if we were to distribute this y times 4x would be 4xy. Y times negative 13 would be negative 13y. And so this works out. Okay, this is a very important step. And now we only have one step left because we're trying to solve for y. So now if we divide by 4x minus 13, this side is going to cancel. Over here we also have to divide by 4x minus 13. And now on the left side all we have left is the y. Now we have y is equal to negative 9x minus 17 over 4x minus 13. Okay? And so we can say f inverse of x is equal to negative 9x minus 17 over 4x minus 13. Okay? Let's do one more of these. Okay, so we've got this rational function. F of x is x minus 11 over x plus 8. Okay, and I've done the first couple steps here. We've got y equals. Then we exchange the y for an x, exchange the x's for y's, and we get x equals y minus 11 over y plus 8. And so we're going to go ahead and get started. We're going to multiply by y plus 8. That's the denominator. That'll cancel the denominator. And over on the left side, we also multiply by y plus 8. Okay, so we'll cancel the denominator. Distribute the x. X times y is just xy. X times 8 is plus 8x is equal to y minus 11. Okay? And now we're going to subtract y from both sides. So we're going to have xy minus y plus 8x is equal to negative 11. And then we're going to subtract 8x from both sides because it doesn't have a y in it. And now what we have left is xy minus y is equal to negative 8x minus 11. Okay? And so now, come up over here, we're going to factor out the y. So now we're going to have y times x minus 1. And y times x is xy, and y times negative 1 is negative y. So it does work. Equals negative 8x minus 11. Okay. Now all we got to do is divide by x minus 1, and we wind up with y is equal to negative 8x minus 11 over x minus 1. And so now we can just simply say that f inverse of x is equal to negative 8x minus 11 over x minus 1. Now let's say that we wanted to know, well, what is f inverse of negative 3? Okay, so if we want to know what f inverse of negative 3 is, we're just going to rewrite the inverse, which is going to be negative 8 times negative 3 minus 11 over negative 3 minus 1. And so in the numerator, we're going to have negative 8 times negative 3 is 24. 24 minus 11 is 13. Over negative 3 minus 1 is negative 4, but we don't leave denominators with negatives, and so we're just going to say that this is the negative of 13 over 4. Okay? So I'm now going to show you another way that you can identify f inverse of negative 3 given f of x. So for f inverse, negative 3 is an x value. But remember that all the x values for f inverse are y values for f of x. And therefore, negative 3 is an output of f of x. So if we set negative 3 as the output of f of x, and then solve for x, which is the input of f of x, then the input x would become the y output of f inverse. So basically what you can do to solve an inverse is take your original f of x, x minus 11, over x plus 8, set it equal to the input of the f inverse, which is negative 3. And now we're going to multiply by x plus 8 to cancel the denominator, multiply by x plus 8 to cancel the denominator, or not cancel, sorry, to balance the equation. So we cancel the denominator on the left, and we get x minus 11 is equal to negative 3 times x is negative 3x. Negative 3 times 8 is negative 24. And now I'm going to add 3x to the right, add 3x to the left, cancel, and we get 4x minus 11 is equal to negative 24. Then I'm going to add 11 to both sides, and I get 4x is equal to negative 24 plus 11 is negative 13. Divide by 4, divide by 4, and I get the same answer I got before. Well, this is saying that x is equal to negative 13 over 4, but that x is for f of x. And so that means for, we transform the x into a y for f inverse, and it becomes y is equal to negative 13 over 4, and that's another way of saying f inverse of negative 3 is negative 13 over 4, okay? And so that's just another way of solving for a specific value in a rational function.